It's amazing what humans have accomplished. Cars that think, machines that learn, healthcare that predicts. The progress of tomorrow has yet to be imagined, but it will rely on data. It will rely on Verve. Verve ensures data gets where it needs to be uninterrupted. Critical power is always running. Servers perform at optimal temperatures. Infrastructures grow safely and responsibly. Applications run without glitches, and life leaps forward again. Getting there takes vision and agility. Our leading experts think beyond infrastructure, connecting the dots to create integrated, intelligent ecosystems, to create a future that takes innovation to the next level. And when business needs shift, we work closely with our customers every step of the way. Together, we ensure they are ready before they ever need to be. Verve provides continuity in our digital world, so we remain unbound, liberated, free to create the next big thing. Verve, architects of continuity.
Good evening, everyone. Dell has also joined. Good morning, Dell.
Good morning. Thanks.
I think this is very important session for all of us. IGBC and LBNL started their joint efforts in 2018 with three objectives: to develop ECBC user guide, number two, capacity building for all the data center stakeholder, and third was to develop case studies for exemplary performing data centers. We are really thankful to our four task force chairmen, Mr. PC Lohia, Mr. Vivek Rajendran, Mr. Raghuveer Singh, and Mr. Pritam Goyal. We got very much good support from AGM members. We have key data center owners, service providers, manufacturers. They really tirelessly worked on this ECBC user guide, and after like hard work of more than 2.5 years, now we have completed. It was launched in the inaugural session by Sri Sanjay Malhotra ji, Additional Secretary, Ministry of Power, and Chairman and Managing Director, REC. Now we would start our technical session 2. At the beginning, I would like to introduce Mr. PC Lohia. Mr. PC Lohia is a mechanical engineering graduate from Birla Institute of Technologies and Science, Pilani. He has 45 years of rich experience and currently working as Senior Vice President, Power and Utility in Reliance Industries Limited. He is instrumental in getting Hall of Fame 2018 for RCP Building 22, Platinum certification for Reliance Corporate Park, Immersion Cup, and many other awards. At this moment, he is serving AGM of IGBC and LBNL and chairing the Chiller Group. Over to Mr. PC Lohia to make presentation on Chiller, what kind of work we have done and delivered for ECBC 2017 for data centers. Over to Mr. PC Lohia.
Good afternoon, everybody. Thanks, Dr. Shivraj. Sorry, are you able to hear my voice?
Yes, sir, we are.
Yeah. Good afternoon, everybody. Thanks, Dr. Shivraj, for giving such a nice introductions. My name is Prakash Louis. I am working in Reliance Industries Limited from last 25 years. As you know that in the data center, large power is being utilized for data computing and all this thing, and which is ultimately converting into heat. Are you able to see my screen? I am not finding. I am sharing the screen, but it is not coming.
Not yet.
Are you able to?
The screen has not yet come.
Is my screen is coming?
Sir, it is visible. Your voice is good. Please go ahead.
Yeah. As you know that in the data center, large amount of power is consumed for data processing and all these things. All these powers are converting into heat. Hence, to maintain the server room temperature, large amount of cooling power is required. Hence, it is essential to design, select, and operate the data center most energy efficient way. Today, I will be presenting energy efficiency opportunity in chiller for data center. Now, I will be covering chiller efficiency, mostly related to the chilled water temperature, condenser water temperature, cooling tower optimization, and various free cooling opportunity in chiller plant, chiller efficiency with respect to the different technology. In the water cooled or air cooled chillers, with increase in chilled water temperature, the power consumption of the chiller is varying. You see that in water cooled centrifugal chiller, if you increase the chilled water temperature from 7 degree to 20 degree centigrade, there is almost 50% reduction in the power consumption. Similarly, in the air cooled chiller, if you increase the chilled water set point from 9 degree centigrade to 20 degree centigrade, there is almost 35% reduction in power consumption. So this is the key point. Then mostly the data centers are operating at 22 to 24 degrees server inlet temperature, and for cooling the air, they are utilizing the chilled water from the range of 7 degrees centigrade to 13 degrees centigrade. Now you know that servers are suitable up to 32 degrees centigrade operating temperatures, and ASRE has recommended 27 degrees centigrade as a server inlet temperature. At this temperature, there is no reliability issue problem or failure problems of the servers are there. Hence, if we have a perfect ceiling in the rack, false floor, and all this thing in distribution systems, we can limit the temperature rise of supply air from air conditioning system to the server rack within range of 0.5 to 1 degree centigrade. Hence, to get 27 degrees centigrade, we can go to 20 or 21 degrees centigrade chill water temperature to satisfy this need. Now, the second opportunity is that once you know that if condenser water temperature reduced by 1 degree centigrade, there is 1.5 to 2% energy efficiency opportunities there. So if we design the system with lower condenser water temperature, there is a less power consumption in the chiller. Now the first part is the cooling tower. For given heat load, range, and all this thing, they are selecting the fill volume. And for the given fill volume, if you increase the base area by some amount, the rain density will reduce and the fill height will reduce, and ultimately the air resistance to the air bath will reduce, and fan power consumption will reduce drastically. And say by increasing the base area of the cooling tower, there is a very good opportunity of saving the fan power. Then second important thing is in cooling tower operation. If the cooling tower operation, if the ambient weight bulb temperature is dropping, whatever the approach is there at particular weight bulb temperature, if the weight bulb temperature is reducing, the approach is increasing. As a cooling tower operation at low weight bulb temperature is to be optimized properly, and a proper operation is to be taken so that you get the best effect on the chiller power consumption. Then for the cooling tower, if you are selecting cooling tower with a proper range, L/G ratio, and all this sizing and all this thing, there is a very good possibility of reducing a cooling tower approach temperature, which ultimately reduce the power consumption in the chiller. Then second thing is that for the given weight bulb temperature, if you reduce the range of water supply to the cooling tower, for decrease in range in cooling tower water, the cold water temperature is being reduced, and which will ultimately reduce the power consumption in the chiller. Then second thing is that if you are selecting the chiller with high chilled water temperature, there is a very good opportunity of free cooling. If you are operating, say, 27 degrees centigrade chilled water temperature, then with 27 degrees centigrade return water temperature, lot of the time the ambient air temperature is less, and you can get a very low cooling water temperature, and free cooling opportunity can be availed. Now I am giving you two examples. One example in which 7 degree delta T is there, 27 degrees centigrade is the chill water temperature, and second case 30, that means 10 degree delta T chill water. So even in the case of Mumbai, if you change the chiller design from 2027 to 2030 degrees centigrade, the free cooling hours available for cooling the return chill water temperature from 2,100 hours to 4,500 hours. That means almost all the free cooling hours will be double by just increasing the delta T by 3 degrees centigrade. Then there is a good opportunity of power saving if you run the chiller in the parallel operation. That means whatever the temperature delta T is there, if you divide into 2 delta T and run the chiller in parallel operation, there is a great saving potential is there. Then third thing is the effect of technology on the chiller power consumptions. If you go from the scroll compressor to the screw compressor and then ultimately to magnetic levitation chillers, your specific power consumption of the chiller will drop down drastically. So by adopting a good technology and all this thing, you can reduce the chiller power consumptions. Then the most important part is that there is a fouling in evaporator and condenser because of continuous operation and all this thing is there. And every increase in fouling is reducing the specific power consumption, increasing the specific power consumption of chiller. That means the power consumption is increasing. And if you can adopt the technology like online condenser and evaporator cooling by online cleaning mechanism, the fouling can be avoided and you will save the power consumption. This is all what I need to say on the optimization of chiller and reducing the power consumption in the chiller section of the data center. Thank you very much.
Thank you very much, Mr. P.C. Loya. We will have question answer session at the last. Now I would request Mr. Raghuveer Singh to be ready for next presentation. Mr. Raghuveer Singh is Director Thermal Management Products at Verve India, Verve Energy Private Limited India. Mr. Singh is driving new cooling technologies and solutions to strengthen the portfolio for like energy efficiency in Indian data centers. He has more than like 18 years of rich experience in data center cooling. Mr. Singh holds BTech honors in mechanical engineering from NIT Jamshedpur. Mr. Singh is extensively supporting to CI IGBC since long time. He is Chairman Cooling Group AGM of IGBC in LBRL. Over to Mr. Raghuveer Singh.
Thank you, Dr. Shivraj. Just share my screen. Is the screen visible now?
Yeah, screen is visible. You can put this on full screen mode.
Yeah, just do it. Thank you. Good evening, everyone. So we have 4 sections in this, and I'm going to cover about the data center cooling part, which includes crack, craw, temperature, humidity control, fan motor efficiency, and so on. So we'll start with crack equipment efficiency. So you can see here the ECBC compliant has minimum guidelines for 2.5 EER in ECBC compliant. So there are 3 levels, level 1, level 2, and level 3. And the level 1 is 2.5 EER, which is rated at AHRI 1360 and 1361 design conditions. So in level 2, it is 3, and level 3, it is 3.5. So level 1 and level 2 as a group, we find this is achievable in the market. The crack units which are currently available with all the manufacturers in the market it is achievable with certain minor changes in the systems. But the level 3, which is 3.5, is difficult to achieve with the current systems. So it requires certain changes in the system. So as a group, we have recommended 3.5 ER for level 3 only when the crack unit is used with the certain economizer systems. So the standard unit will not be able to meet this requirement. The tips and practices for improving the efficiency in crack units. Any manufacturer, so the guidelines currently which you saw in level 2, level 3, these are actually, any manufacturer can achieve with any kind of a changes in component like fan, motor or compressor, coil or air filter. They can make changes in their crack unit to meet these kind of requirements. And these are net sensible COPs. So not total or sensible. So we have to be little clear here about the definition. And when we operate these crack units at higher return air temperature, the net sensible COPs will improve. So as a group, we recommend all the users to use these systems at higher supplier temperature within the ASHRAE guidelines. So when you operate into ASHRAE guidelines of 18 to 27 inlet temperature to servers, your return air temperature will obviously go up. And so this also gives indication for manufacturers to rate and design their systems basically on high return air temperature. Especially the design system should be able to operate and for continuous operation at 38 or beyond. So when you raise the temperatures, it also helps you to improve the energy efficiency or use free cooling coils. Like for example, you can have dual coils, which one can be connected to a cooling tower. And you can also have even a secondary refrigerant coil, which you can use as a pumped refrigerant for system to further improve the efficiency for level 3. And you can also use water-cooled condensers and adiabatic condenser approach to improve the efficiency. So the basic guidelines which we have here in level 1, 2, 3 are without all these extra provisions. Those are just the base units. These extra provisions for efficiency improvements are beyond that, which are actually tips and guidelines for user to deploy at site. And there are some manufacturers in the market who provides, the normal fans can be changed with the new fans, new fan module. For example, the new EC fans can be integrated in the existing systems with better smart controls. And this can be true even for the building HUs, not just for data center actually. And row cooler systems can be also used for data center application for higher density, and the rear door heat exchanger and liquid cooling are the another approach for improving the efficiency. For crack units, we recommend bottom discharge kind of a unit because it always follow a natural airflow pattern. The colder air is denser and is on the bottom side, and your hot, which is the hot air of the servers goes up on the server side, up on the rack, and then it can be easily sucked back to the cooling unit on the top. So when you use a top discharge type of a system in the data hall, it becomes difficult to manage the airflow pattern, and the mixing increases, which reduces the efficiency of the cooling system drastically. The ducted system may be used only for such application where the proper airflow pattern can be used and minimize the ducting losses as well as the mixing of cold and hot air. Another improvement in the fan of especially for the crack units which are bottom discharge type, there are 3 kind of fan arrangement which can be done in the system to improve the efficiency. So the one could be the standard in the crack unit, the fans inside the cabinet, the normal fans of the AC fans basically, and when you without EC motor, when you change that to EC fans, you have energy efficiency improvement, which you can see in blower section B. And then in the C, when you bring down those fans below the crack unit, it is also known as the underfloor, the air conditioning as in-floor fans or below floor fans. So it improves the efficiency by 12 to 14%. So these were some guidelines for the crack unit efficiency. On the air management side, there are basic guidelines in ECBC. There are no, it does not address the air management part, but as a group, we have recommended that we should follow minimum at least cold and hot aisle pattern for the racks placement in the data hall. And we should avoid the mixing. At least you should use blanking plates wherever possible. You should try to avoid the mixing and use variable fans in the level 1 itself. And in level 2, we recommend to do containment mandatory and close all the openings and reduce the temperature rise from the supply point of the cooling unit to the inlet of the rack. So we recommend to use the maximum 3.6. You should try to reduce as lowest as possible to improve the efficiency in the crack units. And this is basically obviously linked to the losses on the supplier side. So when you minimize the losses of the air compared to the actual IT requirement, you will automatically actually improve the temperature. You will basically reduce the temperature rise from the supply point of the unit to the inlet of the rack. And we recommend to operate on supplier control instead of return air control. And when we say from one level to the another level, the next level carried all those the recommendation to the next level automatically. So the additional recommendation in level 3 for air management is to reduce the air loss further down, and the rise from the supplier of the unit supply side to the inlet of the rack is 1.8. This is the maximum we recommend. So some more tips for the for reducing the the air mixing and the improving the overall air management in the data hall is basically the airflow pattern which you follow in the rack. Try to have front to rear. This is important selection of the servers as well as the rack selection, and this also guides the overall efficiency of the crack unit. Have right amount of cold air at right temperature and effectively delivered in front of the server, and then collected it back to the cooling system. So this will overall improve the efficiency. And this is the layout. You can see on the left side is a without containment. Right side picture you can see is with cold aisle containment. You can also deploy hot aisle containment. Both actually avoids the mixing and both improves the efficiency in the cooling units. So you can see here in underfloor we have to minimize the losses. So try to close all the openings in the false floor if you have excess floor, and try to improve also the put blanking plates wherever there are openings in the server racks. Align the racks properly and do containments sealing properly so that there is no loss of cold air. And then when you have achieved this, your return air temperature become really hot to the cooling unit. It improves the capacity of the unit, reduces the energy consumption, and overall the kilowatt per ton is reduced drastically, and you improve the PV. So the another way of doing this is one step we have moved from avoiding the mixing, but then how do we know that how much cold air we need to deliver in front of the server? So we must control it and monitor it. For that, we can follow two methods here, pressure based and temperature based. Both are specified in the user guideline. And the pressure control will have multiple pressure sensors under the floor, and those sensors will be connected to the cooling unit controller to modulate the fan speed based on the pressure under the floor. So when you have a more load in the aisles, it gives you the pressure under the floor falls down and the fan speed is increased. When your load in the cold aisles decreases, your fan speed is also decreased because of the pressure is increasing under the floor. If your speed is at same constant what it was before when the load was lower. So when the load was higher, so you basically have to manage the fan speed control through the pressure sensor. The another way of doing it, which is one step higher of that, is you can have sensors on the top of the servers, on the top of the racks actually, and such multiple sensors can be placed in the cold aisles of multiple if you have a bigger data center, and these sensors will be connected back to the multiple cooling units and the inputs will be shared together, and then your cooling unit's fan speed will be controlled from the top of the inlet server rack sensor. So basically these inlet sensors will smartly increase or decrease the fan speed based on the load changes happening in the cold aisles. This way you try to improve efficiency as well as you provide the maximum of time because you assure that up to the top of the rack you are cooling the servers properly. Your access floor height could be, depends on what is the load in the hall and the size of the hall and various other parameters. So the temperature and humidity control, the next topic. I think we are all familiar with this slide. I will just only want to highlight here that how in each and every category of, if you see here, A1, A2, A3, A4 server classification, there are different guidelines, which means we have recommended by ASHRAE some envelope and some envelope which is allowable envelope. So we have to try to see that we may speak to server OEM and then find out that how many hours in a year I can operate in recommended range of these servers, so that you can utilize the free cooling concepts to improve the overall PV. In temperature and humidity in ECBC compliant, this is just a standard guideline to have a normal control, but in ECBC plus we recommend to have a control in cooling units and also allow supplier control, and system should be able to operate on high return air 38 to 40 degrees centigrade, and also the control should be smart enough to avoid humidification and dehumidification, heating and cooling, these kind of fighting modes together. So the reverse mode operation should be avoided to avoid the extra power consumption when the multiple units are installed in one room. In level 3 of temperature and humidity control, the level 2, whatever we discussed, should be a part of the level 3, and the system should be smart enough to have operate on supplier control, but as with the supplier control, it should have both temperature as well as the dew point control. So this is additional input which is added here. For the fan control, there are this is I think the entire industry today, especially in data center, has already moved to EC fan, which already qualify to these standards. But for the the users on the HBC side, you can see this is the classification of the motor, which is here given for motor efficiency. You can go for IE2 in compliant and IE3 in ECBC plus, and in ECBC super it is IE4. Economization is this is the last topic I have for today. This is very important, and for ECBC compliant, which is actually for less than 100 kilowatt load in data center, it is not applicable as per the ECBC codes. But then when you go to level 2 and level 3, we have made certain guidelines. The economizer you can use up to 50%. At least it should have a minimum capability to modulate up to 50%. If it is up to 100%, you can qualify for the level 3, which is actually super ECBC. In level 2, it's up to 50%, and the economizer could be of any type. It could be air-to-air economizer, it could be water-based economizer, it could be pumped refrigerant type economizer, it could be of any type of economizer. Basically, these are all the concepts to improve the efficiency. So there are direct free cooling as well as the indirect free cooling. Direct free cooling, where you pump the the air directly in the data hall. In indirect, you have a different type of methods. For example, you can have 2 coils in the indoor and use cooling tower outside. You can have a pumped refrigerant type of concept where you do not use water and you improve the efficiency without using the water actually. So you can achieve indirect free cooling by pumped refrigerant method. So with this, I end the presentation. Thank you, everyone. Thanks, Dr. Shivraj.
Thank you, Mr. Raghuveer. We have next presentation from Mr. Pritam Goyal, Senior Program Manager from Microsoft. Mr. Pritam is a certified data center mission critical facility management designer and internal auditor professional with 24 years of rich experience. He has geographically diversified experience in infrastructure planning, construction and operation of data centers, telecommunication centers, cable landing stations, retail stores, and petrochemical plant facilities across Pan-India. Currently, he is serving chairman for electrical system, AGM of IGBC and LBNL. Over to Mr. Pritam.
So are you able to hear me, Mr. Shivraj?
We are able to hear you.
Okay. Let me share my screen. I'm not able to. Oh, so I would like to thanks Dr. Shivraj Daka from IGBC and Mr. Dale Sutter from LBNL to giving me this wonderful opportunity and their continuous effort to make this user guide most effective and useful. I am also highly thankful to the electrical team, Mr. Shirang Deshpande, Shubham Agarwal, Manoj, Kapil, Mahesh ji, and Mr. NK Singh and Mr. MB Patel to provide their specific recommendation, for this user guide during this journey. As you know that in India, data centers are skyrocketing, and the overall energy consumption is approximately 2 to 3% with when by 2022 or so, when the data center will be at their peak. So in electrical user guide recommendation, major three components has been considered for the recommendation: UPS, metering and monitoring, diesel generators. Why only these three? Because these three are the major contributing the major part of this the entire data center facility, where UPS is considering approximately 40 to 45% of the total energy consumption. uh, are you able to hear me, Mr. Shivraj?
We are able to hear you.
Okay, thank you.
You,
Thank
yeah.
you. Thank you. So first going to the UPS, so taking forward the ECBC to 2017 from
Did we lose audio? Or is it only me who's lost audio?
Yeah, Pritham, we are unable to hear you. Even your screen is not visible.
now it is okay.
Yes, we are able to hear you, but your screen is not visible.
My screen is not visible. I have not done anything. Now it is fine.
Yes, perfect. Please put this on slide board.
Yeah. Okay. Okay.
Excellent.
So in the level one, UPS. So we it has been considered three sizes of the UPS: less than 20 kVA, then between 20 kVA to 100 kVA, and then greater than 100 kVA. Why these three ratings has been considered? Because these are the three ratings which are even coming into the modules, and they can be reciprocated into any level of the sizes required in the data center at different part of the facility. So in at level one, the efficiency less than 20 kVA, it is considered at 90.2% at 100% load, and then between 20 to 100 kVA, it is 91 to 9% at 100% load, and then for greater than 100 kVA UPS and their module, the efficiency should be has been considered at 93.8% at 100% load. And it has been in several forums it has been discussed and argued that why we cannot run the UPSs at eco mode. In some facilities, people are running their systems as eco mode as well, which can give a higher level of efficiency, but the availability levels can be vary with the with by using with the eco mode and by using without the eco mode. And moving for further on ECBC plus level 2, the recommendation, the added recommendations are that UPS with less than 20 kVA, the minimum efficiency should be 93.5%. And similarly with the 20 to 100, it should be 94.5%. And then UPS going beyond 100 kVA, the efficiency can be varied at different load at 25%, 50%, and 100%, but the efficiency, the maximum efficiency which can be achieved, is around 96%. So these are the established data in the in the facilities, where our certain of our vendors and our colleagues who are part of these esteemed organization, they have shared this data. And moving forward to super ECBC, the similar the 20 kVA of our UPS, the efficiency is increased to 94.5%, and for 20 to 100 kVA, the efficiency is further increased to 95%. And as you see that, going beyond 100%, 100 kVA, the efficiency should be 97%. So you can see that, how the efficiency level is increased from level 1 to level 3, for the same band from 93.8% to 97%. So so that is why we are saying that when we are moving from ECBC to super ECBC, the buildings, the data center buildings efficiency should be, have approximately 50% more than the non super ECBC buildings. Then the next is, metering and monitoring. So why we have considered metering and monitoring? Because it has been said that, the things which we cannot meter or monitored, we cannot control those things. So if we start with the ECBC level 1, so with section 7.2.4 metering and monitoring, so three levels of data centers has been considered: less than 65, 65 to 120, 120 to 250, 250 to 1000 kV, and greater than 1000 kV. Why as low as 65 kV? Because these days there are edge data centers, where 3 to 4 to 5 racks can made a data center, and their level of power is approximately 60 to 100 kVA. So at 65 kVA, it is recommended that their running kWh should be measured on a hourly basis. And after moving towards 65, the band of 65 to 120 kVA, then the power in kW and its power factor should be measured there. So and going beyond to 250 to 1000 kVA, so some metering for lighting, hot water uses, and the plug loads of anything, they should be added into for the measurement. And for greater than 1000 kVA, so there is need to check the power quality at the input level of the grid power. So where we should able to measure any sag, swell, spikes, so that they should not able to enter into the main data center facilities, and they should not create any type of hurdle or any type of disturbance in the system. So the added recommendation here is that from 65 to 250 kVA, so meter should be installed in every fifth rack, so that the temperature and humidity of servers rack should be monitored, which these parameters, these are the parameters which affect on the overall power usage of the data center. Because the servers are the main component of a data center. Anything which is going up and down in the server level, they are further not affecting on only the UPS power for their power consumption, but they are also affecting the air quality, the air power usage of the data center. And after that, the sum metering of HVAC UPS efficiency, and the PUE measurement should be done with the green grid level 1. So these are the you have seen that specifically it is mentioned that it is either green grid level 1 or ISO 3013 level, which is mainly used in the Europe. And after that, and it has been added into the system because future things can be added into that. Then the energy meter to record the DG set output at and the fuel level consumption. uh, then the data center greater than 250 kVA, load managers should be added into the grid incomer, and at all the energy meters of PDUs, main LT panels, sub distribution LT panels, because they usually give the losses of each and every, not only the servers, but right from the from where the grid power is entering till to the point of usage, which is also very important point, because if we will have all those losses available with us, then it will help us to get a effective and right PUE. And then going back to ECBC plus, with the all recommendation given in ECBC level 1, the added thing into these are, for less than 65, sensor should be added into the rack, every fifth rack at the top of the rack, so that temperature and humidity should be monitored. And the for less than 65 kVA also, the PUE should be measured with green grid level 1. For going above and between 65 to 250 kVA, the the sensor should be installed at every third rack instead of every fifth rack, which we have considered for up to 65 kVA. And then rack PDU strip level monitoring is must, because here it is recommended that the PUE should be measured with respect to the green grid level 2. So where so that's why the metering is required at after PDU, where green grid is recommending, uh, because with this the efficiency, or the number which we will get after PUE will be much efficient than green grid level 1. And after that, as I said, electrical distribution system losses to consider, so that the metering should be done right from the entry point of the grid power to the up to the UPS PDUs, so that we should able to have all the losses available with us. And then the metering and the temperature measurement of battery at UPS room is also considered in this level. Then going beyond 250 kVA, so the health of crack unit and their filters is also important there, because the level of the size of the data center has been increased, and the the capacities of these crack units is quite high. So they are considered approximately 35 to 40% of the overall power consumption of the data center. Then water consumption of HVAC unit, so BTU meters should be installed there. Then branch monitoring of all PDU should be there. And then cell and block level battery monitoring system is must, because the the size of these battery systems is quite big, so which can so monitoring each and every cell is highly important, because in case of power failure, where the backup available is only from 5 to 15 minutes, which is all depends on the user requirement. If the the backup is only for 5 minutes, then you can think that the availability of each cell is how much important. So that's why the measurement of or the monitoring of each cell is highly important. And then going to the level 3 super ECBC, all the recommendation of level 1 and level 2s are and with that the further addition should be there. Less than 65 kVA sensor should be there to measure the temperature and humidity monitoring at each fifth rack. uh, and then load on transformer and DG set should be measured here. And then the PUE should be measured with respect to the green grid level 2. Now when we move from in super ECBC from 65 to 250, the PUE measurement level has been increased from green grid 2 to green grid 3. So what it means here, so the power measurement should be done at the server level instead of after the PDU level. So you can imagine that the number of meters required here, and the the sensitivity of the measurement as Mr. Loya was also saying that, about the server and their, usage of power and, their cooling. So here, the sensitivity is high. So we have recommended to add DCIM here in the system, or, we call in some data center, we have BMS also, but, one step above is, DCIM, where the automation, or these days we usually say artificial intelligence usually come into the picture. And the further recommendation has been given that, data shall be available here in real time, so that, whatever correction measure has to be taken, it should be taken, immediately, by considering the sensitivity of the, facility. And then, so further going, then, total cooling generated and everything, should be efficient. Battery monitoring system at UPS level and battery monitoring system at string level, further move to that. It is again, by considering the, time of backup available, in these facilities. And going away, above 250 kVA, the thermal monitoring shall be at inlet of the IT equipment level at each server by, DCIM. RCA and RTA index, measurement should be done. This RCA and RTA index measurement, it helps to give a, efficient inputs, for not for the electrical system, for the, cooling system, basically. So and it helps to, generate, or it helps to, use the efficient power in the cooling system. So which I have already said is around, 30 to 35% of the overall facility of the system. And then, monitor of airflow delivery versus airflow required for IT load, and check ratio for it should be less than 50%, which has been already explained by Mr. PC Loya and Mr. Raghuveer Singh. So I had only, given the crux of this. So this is about the monitoring. And this, I try to show the green grid, various level where, we should measure, green grid 1, 2, 3. In green grid 1, the measurement should be there, and in green grid 2, it should be after the panel level, and at green grid 3, it should after L3 level, where it is, indicated in green, in the green color. The third one, is the diesel generator, though not, a very vast, recommendations or very vast study has been done, and the study is still under progress. But it is recommended that for ECBC compliant level 1, the DG set should be, 3-star rated, and this DG set rating starts from 19 kVA. It is as per the, recommendation. From it should start from from 19 kV, and it can go beyond 2000 kVA. And for ECBC plus, the, rating should be 4. So going back to ECBC level 1, the SFC, the specific fuel consumption, should be between 245 to 272 so gram per kWh, so which indicates the, overall consumption or the unit generated by the DG set, and the, the pollution generated by the DG set. So the ratio between this will help to generate the minimum pollution and to meet the 3-star rating of the DG set. And at ECBC plus level 2, the rating should be 4. And the SFC, should be 220 to 245. And for ECBC, super ECBC, the rating should be 5-star ratings, though it is it is very, sophisticated or very high efficient DG set should be required for 5-star rating. And the SFC level is less than 220 gram kWh. So I hope that, in now and, in future, we will able to meet all these, 4-star and 5-star rating of the DG set, and the DG set supplier should, move into this direction, and they will. And the overall data center facility would able to have a more efficient, captive power system. So this is all about the electrical system. So over to Mr. Shivraj.
So thank you very much, Mr. Pritam, for giving brief about like what work we have put in ECBC user guide with respect to electrical systems. Now I would request Mr. Vivek Rajendran to make a presentation on IT hardware and management. Let me introduce him. Mr. Vivek Rajendran, Director, Software Engineering, System Management Group, Dell India R&D, Bangalore. He has been in industry for more than 30 years, always in control engineering. Spent 13 years in Dell India, associated with the server and storage management products. And currently he is serving as chairman of IT hardware and management. It is a task force formed under AGM of IGBC and Albina. Over to Mr. Vivek Rajendran for the presentation.
Thank you, everybody. I will share my screen. I'm assuming you guys all of y'all can see my screen. Yes?
Yes, we are able to see it.
Awesome. Thank you for the introduction, Dr. Shiraj. I know we're right at the end of the day for a long day, so it's been a really packed half day, actually, if you ask me. I was looking at the agenda, a lot of the presentations, a lot of stuff. It's like drinking from the fire hose. There's so many things thrown at you. I'm going to keep my presentation short. I want to keep it at a high level to give you the gist of what it is that we've been doing and what is the outcomes of it. There's a lot of data and a lot more things present in the actual guide, and I would strongly recommend you going through, the audience going through that guide, because there's got tons and tons and tons of more other information. As you're seeing on the screen, this is not just by, this is a cross-functional team effort from a lot of people, and I'm extremely thankful to them. So without much ado, let's get into the methodology that we had. So what we did essentially is we bucketized the entire recommendation to two pieces, basically the hardware, and also we added the utilization piece. Now, as you must have already recognized by now, all of the discussions and all of the things that you heard in the last 1 hour regarding cooling efficiency, power distribution efficiency, air handling efficiency, UPS efficiency, all of that, the root cause of all of that is essentially the IT hardware inside the data center. That's what is creating, if to use a bad word, it's probably the problems that we're trying to solve. So this is the source of all of the things. So if you're able to control this in a much better way, there's a cascading impact upstream, which will help, downstream, which will help the cause. So let me quickly dive into the hardware piece. So what we really did is we said, okay, the hardware piece, I'm going to just run through this quickly. We kind of looked at it as 5 major buckets. And we said, first thing is what kind of processor, CPU technologies do you have? What's the efficiency to be gained by using newer generations of CPU? What's the life cycle that we should be able to handle? We could recommend. Then we said, what is the levels at which the air temperature, like Ashay, Raghuveer, I think also mentioned it. You have A2, A3, A4. What would the segregations be? The third important aspect we looked at is what are the main differentiators for power consumption at the server? And there is a huge difference when you talk about power supplies, and I'll get into more details into that. And then the fourth one we said is what kind of power supplies are you going to use? India is not yet fully into an HVDC mode, but it's getting there. So we have an aspirational requirement. And then, of course, the last one that we had was on the airflow direction, if you will. As you heard in the past, there is a level 1, level 2, level 3. Now remember this, there is no hardware section in the ECBC. Hence, we have classified these separately outside of that. So if you see the quick small matrix that you see over here, and I'm going to walk you quickly through all of these things. So from a processor perspective, to basically at level 1, we really don't have any criteria. Could be anything. But when you start getting to level 2, the intent really is to have the number of processors that you have, 60% or more should be in at least 4 years, or no more than 4 years older than the current generation of processors. Why, may you ask? Every generation of processor adds significant amount of efficiency. In the guide, there's a lot more data about that. So suffice to say right now in this context, in this presentation, that as you have more and more a higher density of newer generation processors, your organization, your data center becomes a lot more efficient. And that's the purpose over here. On an ASHRAE perspective, it's plainly evident. ASHRAE for level 1 is really A2, which is the kind of the broad 10 to 35 centigrade. Then you have A2, then you have A3 and A4. A4 is where you actually go all the way up to 45 degrees centigrade. So now there are equipment that can actually allow you to go to A4. And then you say, okay, how do you partition them, allow them in separate subzones? So there's a lot more detail around that that's available. On the power supplies, now this is thing, and I'll give you some more detail about as an example, because I think I saw a chat, there was a question saying, how much of what kind of PU improvements can we see? Hold that thought. When you go just in the next slide, I'll cover a little bit of that. So on the power supply side, you might be surprised to know that when you buy a server, you have options, and not just server, by the way, it's even now for storage, and it's also there for the networking devices, especially in the software-defined networking pieces. You now have options of what kind of power supplies that you can order when you place an order for your server. So you have, obviously there is the uncertified or unclassified. Then you have the bronze rated certified power supplies. What we're saying is 75% of your infrastructure should have at least gold, gold or better, because there's gold, there's platinum, and titanium. So at least 75% has to be gold or better to be a level 2. And if you want to be a level 3, at least 75% should be titanium or better. So there is a segregation of power supplies, and if you have the thought in your head, what difference is this going to make? Hold on, we will get into more details on that. From a power supply input type, we have basically for level 1, level 2 in India, we don't have HVDC. So as a team, we figured like, hey, let's have an aspirational goal and look at for level 3. We look at HVDC, high voltage DC power supplies, power inputs for your data center. Why, you may ask? As strange as it sounds, the number of transformations that happen between AC to DC from the time the power comes into right up to your LT panel is significantly high. You'll find that right from the UPS, you have an input that's AC converted back to DC for your DC power, for your power supplies, for your batteries. Then that gets reconverted back into AC. That feeds back into it feeds into the server power supply. The server power supply then converts that AC back into DC, which is what is required by the server. All of these transformations have losses. And so we cut the middleman out, go straight into the server, gives you that benefit. From an airflow perspective, for level 1, basically, there aren't any specific criteria that needed to be had. But for level 2, the equipment that you have in a data center should essentially have front to back airflow. And the reason for that is to form uniformity of airflow, not a mixing of hot air and cold air. There are some devices still out there in the industry and the market that have slightly different airflows. So in level 2, we're okay to say that, hey, if you have some of those equipment, please retrofit them to have to control the airflows in a uniform way. And essentially for level 3, what we're saying is all equipment need to have front to back airflow. It's uniform airflow, no additional retrofitting to be done. I'm going to come back. So this is the point I was trying to make when you look at, there is no annotate. Oh, interesting. Okay, so there doesn't seem to be an annotate option over here, but nevertheless, if I look at the options, so if you see the one that's in the red box, that's typically what we have in India. And what you would notice over here, and let's take an average CPU load of, let's say, 20%. If you have a bronze power supply, the transfer function efficiency is 81%. So you're talking about 19% of energy that is going to be consumed at the end, at the consuming end of this long pipe. 19% of that is going to be generated as heat, and there's nothing you can do about it. Now that 19% of heat that you generate will require 19+% of cooling, 19+% of all the rest of the things that you saw, the UPS backup capacities, all of those things. So at the source itself, you're inserting a significant amount of loss. Now, if you look at platinum, 94%. So the difference on an average of 20% rated load, CPU loads, you're talking about 13% difference of power at the consuming end. If you do the math, I mean, I've heard estimates of 1% saved at the server translates to 1.4, 1 watt saved at the server translates to 1.4 watts of saved of energy coming in. And I can expect that, especially when you have PUEs of 1.3, 1.2, 1.3, that's easily 20, 30%. There is a huge amount of savings to be had over here. So for the gentleman who had asked the question, does this make a big difference in the PUE? The data over here is, and this is just one factor, mind you. The data over here shows you the opportunity that is there to be had. Quickly moving on to the next, aspect of this. So that was on the hardware at the time at which you buy the hardware and use the hardware, correct? I mean, and install the hardware. Now it comes to utilization. When we start using this hardware, what are the opportunities do we have to find efficiencies? Now, this is an interesting data that I want. Now, don't worry about the age of this data. This is still a 2016. This was I pulled it from some time back. I didn't get the opportunity to refresh with the latest spec, but nevertheless, the data that this tells you is there is a base layer of power consumption of a server. And so if you look at the server CPU utilization at 0%, it still consumes a significant amount of energy. When I looked at the latest servers from Dell, while we are the most efficient, we are still at almost, I think it's about 85 watts for a single rack server. And I think it is for a 2-socket server. So there is a base layer of power consumption, whether you're using any CPU load or not, right? So now, if that with that base layer in mind, every work, the CPU load that gets added is added in 2 parts. So there is a base layer, which is, in this example, I just took it as 200 watts. And if a CPU is running at 20%, let's assume it is 200 watts. So the total power consumed by that one server is now 400 watts. So the efficiency curve is very low as you go with lower efficiency, lower CPU. In this particular example that you're seeing on the screen, there are 4 servers, total power consumption is 1200 watts. The base power consumption is 800 watts of that. And that's not doing any work for you. It is just creating heat. It's not doing any much work. If you have a higher CPU load, you can reduce the number of systems that you need. So your base layer still remains 200 watt, that remains constant. The incremental CPU load that you're talking about now, when it increases to 40%, if you remember the spec in chart in this chart, so at 40%, the incremental load that you have is not a linear graph. So you see a smaller number. The number is actually 280 watts. So the incremental power consumption for 2 servers is now 960 watts, but still doing the same amount of CPU load. And this, of course, assumes that the percentage or all other things are remaining the same. You're not choked on memory, you're not choked on storage. Assuming those are easy problems to solve. But just by having a higher CPU load. How do you achieve this? You can use virtualization. There is now containers. There's a whole lot of new technology that's come in. Right sizing equipment. All these things are very important. So you have to consider how do you feed back data back into the IT side of the house. Partner with the IT side of the house. The key message I want to leave with you is you have to have partnership with the IT side of the house. The facility side of the house needs to partner with the IT side of the house to have a meaningful engagement. So clearly you can see from this chart, significant savings are there to be had. One of the things, and what I think Preetham also talked about was monitoring. So same thing over here, CPU monitoring, absolutely important. So go one level lower. CPU monitoring is absolutely essential. What kind of percentage CPU loads are you seeing in your data center? So for level 1, like I said, there is no criteria. Now, free run. I have personally seen data centers operating on an average CPU load of 12 to 15%. That's really, really low. major opportunities there. So then you start getting to CPU, mean CPU 10 to 40, then greater to 40 for level 3. Same thing with server monitoring. This is very much aligned with what Preetham also talked about. His monitoring for level 3, you need to have a BMS or a DCIM infrastructure for closed loop integration. That's my slide. That's my data. So I just touched upon the high pieces. There is a lot of stuff there is to look at, in the guideline book. I would strongly recommend you to get into that. There's a lot more detail. This is just touching the surface, getting you interested, getting you excited to understand what are the opportunities to be had. With that, Dr. Shivraj, back to you.
Sir, thank you very much. Excellent presentation. I think all the video recordings are available because this program is not conducted on Zoom or WebEx. It is on CIO Hive. All the attendees, they can record it, they can see the presentation again and again for next 1 month. So wonderful presentation. Thank you very much. We have several questions for all of you. But before that, we will have presentation from Dell, and then we will go to question answer session. Himanshu, could you please put the introductory slide for Mr. Dell? Mr. Dell Sartar, welcome to India, not physically, but virtually this time. And we are sure you had like a tough sleep today. It's very early morning for you. Sorry to giving you a lot of troubles, but yes, we don't have any other opportunity. We cannot change the time zone. So kindly consider us. Dell Sartar, professional engineer, is a staff scientist at LBNL, Lawrence Berkeley National Laboratory, USA, where he focuses on building efficiency technologies applications. He leads projects to develop and transfer new technology and stimulate the use of underutilized technologies. He has more than 40 years of professional experience in energy efficiency, renewable energy applications, including 10 years as a principal of an architecture and engineering company, and 7 years as the head of LBNL in-house energy management program. Dell has contributed significantly, not only at global level, but for India, his contribution is very, very significant. He has been known to all data center companies in India, and the energy efficiency he studied in India in 2010 or even before that. And since then, he is continuously working on several projects. At this stage, we are on phase 3, where we have key target to develop the user guide, have enriched capacity development, and also the development of like exemplary case studies for data center, which is not there in India, unfortunately, for data centers. We have already released one case study for Infosys. One more is ongoing for like NetApp, which is in advanced stage. So over to Dell, we would be very happy to hear you.
Great, thank you. I thought I shared my screen. Are you seeing my screen?
Not yet.
We are seeing your pleasant face.
Well, that's good. Let me try it again here.
We are seeing your dashboard or your desktop now.
Okay, well, that's not good. Let's try one more time. Share screen. Okay, how about this one?
Yes.
Okay, now I need to put it in a
presentation.
How about that? Is that good?
Awesome. Yeah, good.
Perfect.
All right. Well, good evening, India. As Shraz said, it's a little after 4 a.m. here in California. It's bright and chirpy. I know you've had a long day, and you know, I appreciate that you've all hung out to the end of this first day of the summit, and thank you. It's been a real pleasure working in India over actually more than 10 years in improving data center efficiency. And what's exciting is the industry has never been more aware and more committed to energy efficiency than it is now. So it's such a pleasure to see the pieces falling into place. A little background on the project. As we know, data centers are very energy intensive and there's a very high growth rate. And because of that, there's a need for increased energy efficiency. Our project since day one has been a public and private partnership to increase the efficiency of data centers in India. And the current goal is the development of energy efficient standards for the Indian data centers. And our target over the last few years has been the Energy Conservation Building Code, or ECBC. Historically, data centers were excluded from the ECBC, but starting in 2017, they were added in. The major participants in the project are the Lawrence Berkeley National Lab under the Department of Energy, the Indian Green Building Center under CII, and the Bureau of Energy Efficiency with the Government of India. And I want to say, and you, because again, the industry has been a major player in the development of our tools and resources. I especially want to thank the advisory group who's worked over the last few years to develop this guide, and specifically, I want to give special thanks to the 4 committee chairmen that we've all heard from previously in the session, the speakers, representatives from Reliance, Verve, Microsoft, and Dell. Thank you very much, gentlemen. The current activities that this project is working on is the development of the user's guide that was rolled out earlier today. The guide, as you've seen, includes a base level as well as 2 additional levels, a stretch level, level 2, and a super efficient level 3. The recommendations will augment the ECBC code, and hopefully over time those recommendations will be adopted as part of the ECBC in the future. In the meantime, or even then, the recommendations of the various levels can be used in rating systems such as the IGBC's Green Data Center Rating System. The guide can be used, or the recommendations can be used as a guide to achieve international best practices. And then the recommendations can be adopted as corporate standards. And in fact, already we're hearing that companies are starting to use the guide and its recommendations in their new data center projects. We've identified and documented some case studies. The first one was rolled out, the Infosys case study, a month or so ago. Infosys was targeting international best practices using warm water, chilled water system, and rear door heat exchangers. And they have also illustrated the use of a continuous improvement process. Soon we'll be seeing case studies from NetApp, where they've elevated the temperatures and used outside air for cooling of their data center in Bangalore, as well as a flywheel UPS. And additional data center case studies will be rolled out in the not too distant future from Intel and others. And lastly, our current activity includes workshops and other activities, outreach activities such as today's summit. So let's take a closer look at data centers and the ECBC. As I mentioned, the latest one was issued in 2017. Data centers are no longer excluded, but unfortunately, not a lot of the standards are specifically relevant to data centers, and some are less than ideal perfect fit. But the ECBC is an innovative code in that it allows for the 3 levels of performance. We've seen that described by the previous speakers. There's the basic ECBC code compliant level. Then there's a plus and a super ECBC. And this is quite innovative at the international level to have a building code that has multiple levels of performance. This allows individual municipalities to pick and states to pick higher levels of performance, and it allows the users to pick a higher level of performance as well and make it a corporate standard. Generally, the data center specific standards were not developed for the higher levels within the ECBC 2017. So that's been one of our goals, was to develop recommendations that could be adopted for those higher levels. So the purpose of the guide was to provide a cross-cutting identification of ECBC requirements relative to data centers. It was to recommend more relevant requirements at higher levels of performance. The guide wants to provide tips and best practices for implementation and operational excellence. And then lastly, we highlight resources to help users achieve the target efficiency levels. The target audience for the guide is Indian data center owners, developers, designers, and operators. As we've seen, there's 4 major categories: room cooling, chiller plant, electrical, and then IT hardware systems and management. And then within each one of those categories, there was a whole list of key topics or key areas of energy efficiency opportunities. Not only did we address the new construction or building code needs, but we addressed the operational best practices that's so important to achieve optimization. For example, the entire IT hardware and software section is pretty much post-construction opportunities, but also say, for example, in air management and controls, how those systems are optimized is going to be the driver for energy efficiency in the long run. We've seen that that besides having 3 levels, at each level we would identify those elements of the ECBC that apply, and then at each level we would identify recommendations for additional requirements, and these would build, or they're cumulative. So, for example, all the level 1 requirements apply to level 2, and of course level 2 to level 3. There was a question regarding, how might this affect PUE? We don't have enough data to know for sure, but we have professional opinions, and this will get refined over time. But the thinking is that with no effort towards energy efficiency, a base case, especially in smaller and medium-sized data centers, is going to be a PUE of around 2. But if we meet the level 1 requirements, the ECBC level 1, we would most likely see a PUE of 1.6 or better in India. At level 2, that would drop to 1.4. And at level 3, we're looking for PUEs better than 1.2. Again, these numbers will be refined as we get better data from data centers that build to these various levels, but this is approximately where we're going to be at. And I think with that, we can go to the Q&A session. Shiraz, thank you.
Mr. Dell, thank you very much. I think it was a great presentation just to showcase like what kind of activity we have done and delivered through ECBC User Guide 2017 for data centers. Now we will have, actually we have received several questions. And just to tell you, this is not a platform where you can have like one-to-one interaction with like all the audience. This is another robust tool developed by CII. So that tool is integrated with the Zoom or WebEx also. So I would request each one of you to have questions with all the participants. So I will just read it out. This is a question to Mr. Loya from Sudhir Malakot, DGM, Jamil Air Conditioners. Since we can operate chiller at 2027 inlet outlet, how about also going with radiant cooling to partially take care of the building envelope load by enabling PAX pipes where possible? Thus, HU fan kilowatt can be reduced. Over to Mr. Loya.
Actually, radiant cooling technology is a good technology. Basically, suits to comfort application where the building envelope is the major load, and the in terms of heat generation, it is in the range of 5 to 10 watt per square foot. But once we are talking about the data center where the heat load is in the range of 200, 400 or 1000 watt per square foot sort of thing, that amount of heat cannot be removed by the radiant cooling. The surface area and all these things requirement and the cost of installation and space requirement is very high. And second thing is the server cooling is being done by this by the server fan sucking the air. So ultimately, radiant cooling has to cool the room air, and that room air is to be supplied to the server. So such a huge amount of heat generation cannot be taken by the radiant cooling. This is what my view is.
Okay, because Dell has international experience, he has visited several data centers across the globe. Dell, would you like to further elaborate this?
Well, I think the question was a little bit more specific in that it mentioned that the radiant cooling would take care of the envelope load as opposed to the IT load, which typically is a very small amount compared to the IT load. But you know, a data center can be in a bigger building or in a campus that includes a lot of offices, and all the benefits of warm water cooling that was described in terms of the increased performance of the chiller plant and the number of hours of free or compressorless cooling, economizer cooling, all those can accrue, you know, in a warmer water cooling system for offices as well. So I think that if you have a campus that has, say, a dual loop, you'll still need chilled water or for dehumidification. So in a data center, or even in a radiantly cooled office, that would be for your DOA, the dedicated outside air unit. You do your humidity control there, but then the bulk of the cooling in, say, the office complex could be accommodated by warmer water cooling in the radiant system. But I agree that we really can't use radiant cooling as the primary cooling mechanism in a data center.
Great. Thank you. I think it is very important to shift some load from data center, and that can be done through like radiant cooling. Thank you, Dell and Mr. Loya. Second question is, I think it is related to Mr. Raghuveer. There is a question from Srinivas Upa, Managing Partner, Design Corporation. He has asked, like, we are green building consultants, how we can extend our services, or we can see opportunities in data center market through CFD, like computational fluid dynamics. Raghuveer, could you please reply?
Yeah, I think I would say the data center segment is really booming, and it's growing. Like I think we saw today from early afternoon, then we saw a lot of presentation on what is the growth happening in Indian data center industry. So CFD is definitely, you know, basic tool which can help to authenticate the design part. So I definitely see a lot of opportunities. But what happens is, like, you know, the bigger organization nowadays have got their own team to do the CFD simulation. And so you know, whenever they design data center, they do in-house also simulation. But whenever they hire external consultant, they expect consultants to also do simulation of their design and validate it. So CFD is definitely a value addition tool. I definitely see future for it. And it is not just for the data center hall alone. I think we are talking much bigger picture than just a data center cooling. It's a, you know, overall building airflow pattern outside, like your genset, even other services outside, chiller, and the overall building, how the overall airflow pattern and the heat flow is happening. So it's overall simulation of and actually which is important to do. So it has definitely got a lot of things to do in future. Yeah.
Great. I think this is also a very important question, and because India has not got the saturation like CFD, but US has many applications for CFD. Dell, would you like to further elaborate it?
Yeah, I think one does have to approach CFD with some caution because it's a garbage in, garbage out deal, and the fineness, the resolution of the CFD model is pretty important. But I want to reinforce the concept that we have to look outside of the data center as well. I mean, as we see double-digit megawatt data centers and the amount of cooling that has to happen, the design of like the cooling tower layout and the prevailing winds and how, you know, one row of towers can affect another row of towers is pretty important. So I agree that, you know, we have to take some of that same modeling capability that we might use on the inside of even within a server itself, and then within the data center, and then on the outside of the data center in terms of airflows and cooling. So, you know, it's a good tool to measure, to estimate the differences of options and hopefully pre-test the system before it's built.
Okay,
Yeah, in fact, when Dr. Shivraj, you know, just like to add something here, you know, now a lot of data center campuses being announced. Imagine, you know, in a campus, you have got a building and there is someone coming near to you and he designs something else for the cooling approach, and it can always affect the nearby other buildings actually. So simulation is really, really going to do a lot of things in future. So in overall data center campus, simulating the new upcoming buildings, how overall airflow pattern will be, and then overall simulating the campus, the existing houses and the new buildings which are coming up.
So I think it is important because recently Ministry of Electronics and Information Technology, they have announced the draft data center policy where they are not talking about like only data center. They have put several big picture for data center, like data center parks would be there across the country. There would be data center special economic zone for data centers. So I think there would be more and more requirement for this area in India. Okay, I think Vivek is resting from some time. We will have question to Vivek. So it is probably very like problematic area to estimate saving from virtualization. Which tool shall be used to predict saving from virtualization? Please name the tool. It is a question from Mrs. Ravni from Kanjav Consultant. They are doing a lot of projects all across the country. And very recently, these questions we got from one of the consultant where they are doing the data center, green data center certification. And they are very much interested to follow the ECBC user guide that we have recently developed. Over to Mr. Vivek.
Dell tool. You just use the Dell tool. So no, I'm just kidding. So Dell is just one of the companies that has tools that can give you a lot of the savings from a virtualization aspect. We have a tool which gives it to you right from a server level, rack level, and it can actually go down to at a VM level as well. So VM level, server level, rack level. So I'm not trying to sell Dell tools, but we're not the only company in the world that does this. There are quite a few companies in the world that can do this virtualization monitoring capabilities, and power savings specifically is a very big use case in that. So if you're finding it difficult to find those tools, do let me know. Like I said, I know of Dell. There are a bunch of them that I think, I believe even Schneider also has it, because they also use the same Intel technology that is used to get it. So I don't know, Dr. Shivraj, do the participants have our contact IDs, or is it? So if they have it, I mean, if you're finding it difficult to get it, drop me a note and I'll get you specifically what you need.
Sure. This inquiry, in fact, we got about like 2 weeks back, and we will connect you with Kanjav Consultant. You can guide them like the tool is used. But in fact, because this is an open forum, it is not like they are the only one who are doing data centers. There could be many consultants and they may find same problem. So it would be good if you share some of the name of these tools that can help in like virtualization. But
yeah, so the tool that I have from Dell is called Open Managed Power Center. If you just go to Dell.com and look for it, you'll get it. So it's largely a free tool, so you don't need to pay for it. But there are a lot of other tools that can do this for you.
Okay, fine. I think next question is for Dell as well as Raghuveer. First, we would like to hear from Dell, because there are many immersion cooling companies are there in US. They have also deployed a lot of solutions. So Dell, this is a question from I don't know who has posted this, but immersion cooling is safe to use. Sorry, immersion cooling is just a moment.
Dr. Shivraj, the question was before that whether immersion cooling is safe to use or not. So
Correct.
I reply on this. Yeah.
No, actually here reply will not work because it will not be going or broadcasting to like CI high plane.
Okay.
You need to have the answer for it.
Okay.
So there was a question that says, is immersion cooling allowed per the standard? And is ECBC looking for the same? Well, again, I mean, ECBC, I mean, immersion cooling is an advanced technology that wasn't even in the sparkle in the eye as ECBC was developed, but it's certainly included in the guide. And we talk about liquid cooling, and I think liquid cooling is just starting to get some traction in India, a little bit more highly developed in the US and Europe. And immersion technology is one of the, one of several liquid cooling technologies. Typically, the closer you get the cooling fluid to the heat source, the more efficient the overall system is. So an immersion system, which basically you submerge or you immerse your IT equipment in a non-conductive fluid. So the hot components are under not water, but under the fluid. So you can't get any closer than that. So immersion systems are, safety somewhat depends on the type of fluid and how it's implemented, but I would say that they're being deployed safely and effectively in numerous applications. And I believe we have a speaker tomorrow from one immersion company, but they're one of many, and we've talked about maybe having a liquid cooling workshop for India. Again, it's more advanced technology. A lot of times we recommend as a transition technology going to rear door, but these aren't mutually exclusive. I mean, many data centers will see a combination of liquid cooling technologies. They may have some older components that are cooled with rear doors. Then they might have denser, newer components cooled with cold plates and on-chip cooling. And then they might have an area of the data center that utilizes immersion cooling. So they don't need to be mutually exclusive, and they're all good technologies.
Thank you, Del. Actually, I do have one question here for immersion cooling. So is it good for like enterprise data center, or is it also good? Is it also good for like co-location, or any data center can adapt it? Any opinion?
Well, that's a good question. I mean, obviously, any cooling technology is more difficult in a co-location facility because the vendor or the colo provider has to be responsive to a variety of customers and customer needs. I think the key is for colos is we need to get the warm water or the tower cooled water into the data center. So just having a warm water loop available to the customers in a colo facility is the first step. And then many liquid cooling systems could tap directly off of that. But if you have a more conventional customer that wants a crack unit, crack units are readily available that are water cooled. So you would just tap into that system, and instead of running to an outside air unit, you would just use the warmer cooling water in the data center for a liquid cooled crack unit.
Great, thank you, Dan.
Enterprise data centers, again, I mean, you're not going to have one liquid cooling solution for the entire enterprise, because enterprise data centers typically have a mishmash of IT equipment. So, but what we're seeing, like in our enterprise data center, is we're getting racks, or what we call clusters, which are like rows of extremely dense computing, and those require or benefit by the liquid cooling.
Great, thank you, Del, for like very nice explanation. It could be like a good opportunity for all data centers, but yeah, there could be some specific reason for it. Yeah, one again question to Del only, because Pritham is not there. He has some family marriage, and he left because of that. Have we considered the rotary UPS in ECBC user guide?
Well, I think we established performance specifications for UPS, so certainly rotary UPSs that would meet those requirements will be, will meet the recommendations or the requirements of ECBC. And as I mentioned, our NetApps case study involves a rotary UPS. So it's a viable technology for UPS and one that's worth exploring.
Yeah, I think NetApp Case-D would resolve a lot many problems with regard to free cooling. There could be many opportunities for like several data center companies in India. Right now, they haven't explored, but it could add a new area for new data centers, as well as there could be some retrofitting for existing data center to accommodate free cooling, maybe like 5%, 10%, 20% based on climatic conditions. Yeah, very interesting question. But again and again, we are going to Dell. Sorry to have a lot of troubles, but yes, it is a good opportunity to resolve lot many questions. And sorry, yeah. So there is a question from IBM. The person is asking, cooling solutions are many in data center. Which cooling technology is best for modern data centers? This is number one. Number two, when user guide would be updated again, we wish to be part of the development and upgradation.
Well, I mean, I don't think there is a, it's hard to pick a winner. I mean, there's different technologies are going to work better under different conditions. I would say though, as a whole, compressorless based air conditioning, whether it's the use of outside air or a cooling tower system, or even a dry cooler, if you have, say, liquid cooling that's at a warm enough temperature, that's the key. I mean, warmer temperatures and compressorless cooling is going to drive the best technologies in the future.
Thank you, Del. I think it's a long time now. We haven't gone back to Mr. PC Loya. Loya sir, one person is asking, like there is a guideline from Bureau of Energy Efficiency called like Schedule 21. So could you please elaborate like how it is related to COP and ICER, which is like very much specific to like Indian conditions?
There is a IS 16590 is the Indian standard for the chiller, and BE has extended this thing based on the Indian seasonal energy efficiency ratio. They have defined a different level of energy efficiency ratio. For level 1, some energy efficiency ratio has been given, and for star rating 1, 2, 3, 4, 5. So they have divided the chiller performance under the seasonal energy efficiency ratio 5 category, and under schedule 21. They have published for star rating 1 what is the ISEER value is there, for star 3, star 4, star 5. So that is available there. You can download from the BE website.
Great, sir. Thank you. One question is to Vivek. How much saving one can expect from server refreshing?
Quite a bit, actually. So if you look at the generation changes from 8th gen proc to the 9th gen proc, it was almost about, if memory serves me right, it was almost 8 point some X difference. So which means you're talking about, even if you keep all other constraints common between memory, your storage, your networking, you keep those constraints constant, you can easily expect to see a 20 to 30% savings in hardware. So if you were running 100 servers, and when you upgrade to the new proc families, you can very easily look at 20 to 30% savings or reduction in number of servers. So, and again, this is assuming the same workload is moved on. But here's the interesting challenge. What I've noticed is when new proc refreshes or new server refreshes happen, it happens because there's a business requirement to change the workload or increase the workload or add new workloads. It is never really done from an efficiency point of view, right? So people look at this and say that, hey, unless there is a business need for me to move because there's an operating system that has gone end of life and I have to migrate from Windows 2012 to 2019, that's forcing a trigger of a refresh. Very few people look at it from an efficiency point of view, because if you bring in this number your ROI or your ROI of this investment is actually pretty quick, right? It creates a lot more capacity, creates a lot more things. So I'll give you an example. In my own labs, I have removed about close to 60% of my older generation hardware. Because remember, I'm an R&D lab, so in my own labs, I have roughly about 1,000 servers in my lab, and in my own labs, I have reduced it from we're right now at about 400 odd servers. A huge number of servers have been reduced, made redundant. My server CPU load has gone up to 70-75% average server thing. So all of these things have helped significantly reduce things. Now, reduce the source of heat and or those things, you get a you get a cascading effect, and which improves your efficiency all through. So long answer, efficiency is significantly impacted, not by just because of process change, reduced number of sources of heat, if you will.
Thank you. I think
Shraz, I'd like to add something to that, because there was a subtlety there that might have been missed. And that's that if you take an existing server that's, say, 10% loaded, and you replace it with a new server that's 2 or 3 times more powerful, the energy savings is very low. I mean, instead of now being 10% loaded, you'll have a server that's 3% loaded. So the key to the energy efficiency is working in a virtualized environment that allows you to increase the utilization. So now if you have a virtual environment and you can go from the 100 servers to 20 or 50 or whatever the number is, that's where you get this. That's where you get the huge savings in hardware and energy is in a virtual environment where you're increasing the utilization as well. If you don't increase the utilization, you're not going to get much savings.
Oh, thank you, Dale. That is an excellent point. Yeah, I mean, you're absolutely right. It's when the CPU ratings, so utilization is high, is when you're going to get any benefit. Otherwise, you get a nice fancy new badge. That's it.
So we will have last question from Dell, because it is coming on ECBC. So Dell, please explain like how much PUE can be reduced with adoption of like ECBC user guide for a colocation data center, or maybe like enterprise data center. It is a question from one of the MEP consultants.
Yeah, I think I tried to point that out in that summary graph of the PUE of going from the upper ones to 2 to down to 1.6, 1.4, 1.2. And then I think there was a subsequent question, which was a good question. I mean, climate does have an impact on efficiency and PUE, but the reality is that there are compressorless options in the most severe climates, especially as you look at liquid cooling. So, I mean, it's going to be more difficult in a hot and humid climate to achieve a 1.2 PUE than compared to, say, like Bangalore or San Francisco. But, we see data centers in as extreme environments as like Phoenix, Arizona, that has monsoons and very high temperatures here that have PUEs well under 1.2. So that would be the target. I mean, that would be the potential.
So thank you very much, Dell. I think we are running late now. I would like to summarize the day. We had excellent industry leaders from data centers, those shared their experience, and also we had domain experts who spoke about the latest things on data centers. And data center is growing market, as it was said by chief guest Mr. Sanjay Malhotra. Like, it was the best of the time for data center, but worst of the time for like human beings to have more and more struggle with COVID. So today we had wonderful day. More than 1,100 participants have registered for this program. We had participation from 26 countries. Several leaders presented and also showcased like how India can become like a digital hub or like data center hub. There would be more and more policies coming up from Ministry of Power, Ministry of Electronics and IT. And the key highlight of today's session as well as this data center summit is launching of like ECBC 2017 user guide, which would set like new example for data center to have the energy efficiency, as well as it has defined like component level as well as equipment level benchmarking and a tier approach like level 1, level 2, and level 3. It's a great news. Like India has now one case study on Infosys data center using like RDX system. We are developing the NetApp case study. It is like advanced state. Very soon we'll get comments from Dell and we will try to close it as soon as possible. Few other case studies are ongoing. Finally, we are very much honored, privileged to thank all our AGM member, and a great thank and special thanks to our task force chairman, Mr. Lohiya, Mr. Raghuveer, Mr. Vivek Rajendran, and Mr. Pritam Goyal. Thank you. It was a great contribution from all of you. For tomorrow's session, which will start at 14:30, but try to join at like 14:20. Tomorrow we have very special guest. We have Jayesh Ranjan, who is Principal Secretary, IT and Commerce from Telangana State. He is very, very active in IT department and they have done a lot of activities. They have developed the policies for data center. He would be speaking on state policy matters for data center. At the same time, we have a very key speaker from Ministry of Electronics, Srimati Uma Chauhan, who is like scientist G and looking after and heading e-governance. And very recently in early November, they have announced draft data center policy 2020. She would be sharing knowledge on these fronts. So friends, thank you very much. I don't know whether you are aware about this or not, but I just showcase you how to see the conference as well as attend the conference. You just go to CIO Hive Digital lobby. There you will find like data center program, and you can find the lobby. Lobby would be having some all the registered participant where you can have like B2B meetings with them. It has shown the conference. Each of the sessions are having different link for like WebEx or Zoom. You don't need to worry about that, but you can directly go to the session which is ongoing. You can attend that session. Like this is the session we just completed because this time is already over. You can also see the library. You can have some good networking, and you can explore like what things are there on this platform. So thank you very much. Have a wonderful day.
Thank you very much. Thank you very much.
Thank you very much. Thank you, Dan. We have given trouble to you. You had like very hard sleep today. Thank you very much. Have a nice day.
Thank you.